And I'm talking about the statement 8.0.2. Here we have a prime number p. Then these results say that this prime number p always divide this number p minus 1 factorial plus 1. Wilson theorem all say that any prime number p always divides the number p minus 1 factorial plus 1. In congruence term, we can write in this way: p minus 1 factorial is congruent to 1 modulo p. So either you say that p divides p minus 1 factorial plus 1, or you say that p minus 1 factorial is congruent to minus 1 modulo p. Both statement is same. Either you write in the congruence form or you write in the simply in the division form. So Wilson theorem say that any prime number p always divides p minus 1 factorial plus 1. And I believe that all of you know what is meaning of factorial means. Suppose we have a positive integer n, then the product n into n minus 1 into n minus 2 into n minus 3 and so on into 3 into 2 into 1. This product we call factorial n, and we denote by this symbol n and this symbol. So that is meaning of factorial. So p minus 1 factorial means p minus 1 into p minus 2 into p minus 3 and so on into 3 into 2 into 1 last term. And this product is congruent to minus 1 modulo p, means p divides this product plus 1. And I think the proof is not so lengthy, so I'm going to explain the proof of this Wilson theorem. This is a half-page proof. So see, here only condition is given that your p is a prime number, and you know the range of prime number. Prime number always start from the 2, 3 is also prime number, 5 and 7 and so on. So see, suppose your p is 2. In first case, if p is equal to 2, then think about this integer, because p is equal to 2, then p minus 1 factorial is nothing but 2 minus 1 factorial plus 1, and this number is equal to number 2, and you know that 2 is divisible by itself 2. That means if p is equal to 2, your Wilson theorem holds, means true. Again, if p in next step, you can also observe that if p is equal to 3, then think about this integer 3 minus 1 factorial plus 1. This is same as, this is nothing but the number 3, because 3 minus 1 factorial is 2 factorial, 2 factorial is equal to 2, 2 plus 1 is equal to 3, and 3 is divisible by 3. That means Wilson theorem also holds when p is equal to 3. Now, so for in general, you assume that your prime number p is greater than 3, means p maybe 5, maybe 7, maybe 11, maybe 13 and so on. And after that, we consider this set which consists of element from 1 to p minus 1, 1 to p minus 1. So if you choose any element inside S you call A, then you can see that GCD of A and P is always 1, because A is a positive integer but less than P. So that's why, and A and P is, and P is a prime number, that's why GCD of A and P is equal to 1, because prime number only divided by itself and 1. So that's why GCD of A and P is equal to 1. And that is true for all A inside S. And that means each element inside S has its inverse, and we have already discussed what is meaning of inverse of any element A modulo P. This is nothing but the a solution that satisfy the equation X congruent to 1 modulo P. That means here X is nothing but A inverse, and we have already discussed that the solution is unique, and we'll give the notation A power minus 1, and that will call the inverse of A modulo P. Any doubt from your side? So this is a solution. We have given this notation A power minus 1, and we call A inverse. That means each element inside S has inverse, because X is congruent to 1 modulo P, always has a solution, because GCD of A and P is equal to 1, and 1 divides 1. That's why this equation always has a solution, unique solution. That solution is denoted by A power minus 1, and this is the inverse of A modulo P. And we already discussed that this inverse is unique, and in inverse of inverse it's nothing but same element. Now here we claim one thing, that if any element A inside S is equal to its inverse, then that element is same as 1 or P minus 1. For example, think about the P is equal to 5. For time being, think about P is equal to 5. Then construct our set S. Then S will have element 1, 2, 3, and the last element is 4, because your P is equal to 5. So last element is P minus 1. So this S has only 4 elements when P is equal to 5. So S has element 1, 2, 3, and last element is 4. Now you tell me, what is the inverse of 1 modulo 5? Anyone?
So
What
one.
is 1? Good. So inverse of 1 modulo 5 is equal to 1, because 1 into 1 minus 1 equal to 0. 0 is divided by 5. So inverse of 1 modulo 5 is equal to 1. Good. Thank you. So that means inverse of 1 is equal modulo is itself. Now what can be the inverse of 2 modulo 5?
3.
Because we are going to find inverse of each element inside S. So what can be inverse of 2 modulo 5?
3.
3. Good. Thank you.
3.
3. Good. Thank you. So that means inverse of 2 is different from 2. But inverse of 1 is same as 1. But inverse of 2 is 3, which is different from 2. That's why I came here. Now, what is the inverse of 3 modulo 5?
2.
2. Good. Which is different from 3. Good. Thank you. And what is the inverse of 4 modulo 5?
So 4.
4. 4. So in
4.
this, when you take P equal to 5, you observe that there is only 2 elements inside S, which is the equal to its inverse, like 1 and 4. These are only 2 elements which is equal to its inverse, because inverse of 1 modulo 5 is equal to 1, and inverse of 4 modulo 5 is equal to 4. But you have observed that inverse of 2 modulo 5 is 3, which is not equal to 2, and inverse of 3 modulo 5 is 2, not equal to 3. That means if you take P is equal to 5, then we observe that there is only 2 elements inside S which is equal to its inverse, namely 1 and 4. Now, in another example, suppose that we choose another prime number, for example, P is equal to 7. In this case, your set S will be having element from 1, 2, 3, 4, 5, and last element is 6, because S has last element P minus 1. I refer here you p is nothing but 7. So your last element will be 6. So S will have element has 1, 2, 3, 4, 5, and 6. Now one by one, you tell me what is the inverse of 1 multiple 6? 1 multiple 7, sorry, 1 multiple 7.
So
1.
1, sir.
1 good. So remember that this is the, here in this case, inverse of 1 is itself 1. That's what I'm going to claim in the this is proof. Now come to the next element 2, and what is the inverse of 2 modulo 7?
4.
4, good, 4. That is different from 2. And what is the inverse of 3 modulo 7?
5.
5.
5, 5, yes, 5, yeah, good. Which is different from 3. What is the inverse of 4 modulo 7?
2.
2, good, yes, thank you. So inverse, that is different from 4. Now what is the inverse of 5 modulo 7?
3.
3, sir.
3.
Good, thank you. So it is different from 5. And what is the inverse of 6 modulo 7?
6.
6,
6,
sir.
because 6 into 6, 36 minus 1, 35. Yeah, good, thank you. So see that again, when p is equal to 7, you observe that only two elements in the set S has its inverse, whose inverse is same, like 1 and p minus 1. When your p is equal to 5, you have observed that 1 and 4 are the elements who are equal to its inverse. When p is equal to 7, you observe that, just observe that there is only two elements, 1 and p minus 1 is 6, because p is equal to 7. So 6, 1 and 6 are only two elements which are equal to its inverse. Similarly, if we choose p is equal to 11, you can find same trend, that 1 and 10 are the only two elements which are equal to its inverse. And that is my claim. In general, if p is equal to 5 and any element inside S is equal to its inverse, then that A is nothing but 1 or p minus 1. That is my claim, and we are going to verify that my claim. This is a pro claim, is not a big one, so I just verify that. So what is my claim? If whatever p is choose doesn't matter, and if any set element inside S is equal to its inverse, then that element is nothing but 1 or p minus 1. 1 and p minus 1. There are only two elements which are equal to its inverse. Otherwise, you can just observe that any element which is different from 1 and p minus 1, whose inverse is also different. Now, see, so what is information you had? If A is equal to its inverse, then you have to verify that A is nothing but 1 and p minus 1, 1 or p minus 1. So one by just because if this is information we have, so we start here. Suppose we have A is equal to its inverse. That means A inverse, that means X congruent to 1 modulo P has a solution. That solution is what A inverse. So A inverse is same as is congruent to 1. 1 is same as A n congruent to 1. That means इस दोनों को A और इनवर्स को मल्टीप्लाई करोगे और P से डिवाइड करो तो आपको रिमाइंडर 1 ही मिलने वाला है. That's why A minus 1 is divided by P. That's why, right, 1 is congruent to A n minus 1. And here, instead of A inverse, you just put the values A, because A is same as A inverse. That's why this number is coming A square, because A and A inverse both are same. That's why, right, A square modulo P. I should write here also a modulo P. Sorry for that. So I should write here also modulo P here in this line. So that means A square modulo P. So finally we are getting that 1 is congruent to A square modulo P. That means P divides 1 minus A square or A square minus 1. Both are same, because you know that if P divides N, then P also divides minus N. Yeah, just converse, P divides minus N, then P divides N. So from here you can say that P divides A square minus 1. And you know that a square minus 1 is something you can write in as the a minus 1 into a plus 1. That's why, right? That means P divides this product a minus 1 into a plus 1. And because P is your a prime number, P is your prime number, that means P either divides a minus 1 or a plus 1. A plus 1. So see, in that's why, and C, your A is coming from the set S, which has element from 1 to P minus 1. Think about P divides A minus 1, और A का जो मोमेंट है 1 से लेके P minus 1 तक ही है. That means A can be either 1 होगा तो 1 minus 1 0 हो जाएगा, तब P डिवाइड कर सकता है, बिकॉज P दो ही एलिमेंट को डिवाइड करता है, आइदर वो 0 को डिवाइड करेगा या खुद को डिवाइड करेगा, क्योंकि ये सभी नंबर उससे छोटे हैं या बराबर, मैक्सिमम बराबर हो सकते हैं. दैट्स व्हाई ए के ऑप्शन क्या होगा? दैट्स व्हाई ए ईदर 1 in this case, or in this case A is either or is equal to A P minus 1. That means P minus 1 plus 1 will get the P. So from here A is equal to 1, from here A is equal to P minus 1. That's why right here P is prime, and the moment of A from 1 to P minus 1, that's why A is either A is equal to 1 for this case, or A is equal to P minus 1 from this case. So that's how you verify that if any element is equal to its inverse, then that element is either 1 or P minus 1. So that is my claim. Now, after verifying my claim, I come to the next step and I consider this product factorial P minus 1, and just I write each term, what is meaning of P minus 1 factorial. This is nothing but the product of these P minus 1 terms from 1 to P minus 1. So that's why I write here 1, 2, 3, 4 and something. Now think about, in this product, you know that we just observed that inverse of 1 is itself, and also inverse of P minus 1 is itself. But we don't know what is the inverse of 2 in between 1 to P minus 1. Like see, here I try to explain something. Think about, suppose P is equal to 4, what I did in the proof. Suppose P is equal to 5, then think about P minus 1 factorial, that means 4 factorial. 4 factorial is nothing but this product 1 into 2 into 3 into 4. You know that inverse of 1 is equal to 1 itself. Inverse of 2 is nothing but, what can be inverse of 2 modulo 5?
3.
3, okay. So that's why we make the group of 2 and 3. That's why I make the bracket in between 2 and 3. And what is inverse of 4 and what is inverse of 3?
2.
2. So that is they are inverse to each other. 2 is inverse to 3 and 3 is inverse to 2. They are inverse to each other. And that's how you make the grouping of 2 and 3 element. And you know that inverse of 4 is 4 modulo 5 is nothing but
4.
4. That's why जो एलिमेंट अपने आप के इनवर्स है उस एलिमेंट को हमने छोड़ दिया, अदरवाइज जो एलिमेंट एक दूसरे के खुद के इनवर्स नहीं उसको ग्रुपिंग बना दिया, इनवर्स के साथ ग्रुप बना दिया. नाउ थिंक अबाउट E modulo 5 system. E modulo 5 system 1 can be written as 1, and this product is coming in 2 into 3 is the number 6, and 6 in modulo 5 is nothing but 1. So this element I write 1. This is congruent symbol, not equal. See that difference between this symbol. This is equality. This is congruent symbol. Either I write modulo 5, doesn't matter. So this is equal to 1 into modulo 4. This 4 is coming just. Now think about this product. This product is same as 4, and 4 in modulo 5 system can be written as 4 is nothing but -1 modulo 5. So that's why Now come to the another what how make the I am making the grouping 2 into 3. Now come to the when p is equal to 7. In this case, I consider the factorial p minus 1. That means factorial 6. Factorial 6 can be written as in this product. Now, so this is your factorial 6. In this product, we have to group those elements which are inverse to each other. Like see that you know that one is inverse to itself, so that's why I make this element separate. And you know that what is okay? What can be inverse of 2 multiple 7? Anyone?
4.
4, sir.
4. That's why see, you know that inverse of 2 multiple 7 is 4, and conversely, what is the inverse of 4 multiple 7?
2, sir.
2.
So that's why I make those elements in this product which are inverse to each other. The 2 and 4 are inverse to each other in multiple 7 system. That's why I make the group of 2 and 7. I put side by side in this product. Okay, आप जानते हो प्रोडक्ट कम्यूटेटिव होता है, एलिमेंट इधर से उधर मूव करा सकते हो. So just I make those element as a single term which are inverse to each other. Now, तो 1 हमने कवर कर लिया, 1 अपने आप आया तो इसका इनवर्स खुद है, 2 का इनवर्स 4 है, 4 का इनवर्स 2 है, तो एक साथ हमने रख लिया. फिर come to the 3 and what is the inverse of 3 multiple 7?
5.
5, sir.
5. And converse, what is the inverse of 5 multiple 7?
3.
3. That's why I make the group of element 3 and 5 because they are inverse to each other. And you know that inverse of 6 multiple 7 is itself. That's why I make this one. So in this way, I'll write the factorial p minus 1. In this case, factorial 6. And see, in factorial 7 system, in modulo 7 system, this element is nothing but 1. I think all of you are agree. In modulo 7 system, this element is nothing but 1 because this is 8. 8 is equal to 1 in modulo 7 system. Agree?
Yes, sir.
Yes. And also this product which are inverse to each other in modulo 7 system, this element is nothing but 1 in modulo 7 system because this is 15 and 15 can be treated as 1 in modulo 7 system. That's why I put instead of this product 1 and this instead of this product I write 1 because these are all are 1 in modulo 7 system. This which are that's why making this type of grouping of those elements which are inverse to each other. Now similarly in the last example, suppose p is equal to 11. In case of 11, think about the factorial p minus 1, that means factorial 10. In factorial 10, factorial 10 is nothing but this product starting from 1 to 10, and one by one we are going to find inverse of each term one by one step by. So you know that inverse of 1 is itself, though I make separate because ये element अपने आप के inverse है, तो इसका कोई grouping नहीं होने वाला है. Think about the what is inverse of 2 modulo 11?
6.
6. And inverse, what is inverse of 6 modulo 11?
2.
2, sir.
2. So that's why I put 2 and 6 side by side and make a group. तो ये सेल एलिमेंट को अपने एक साथ पकड़ लिया. 1 को बिकॉज 1 अपने आप के इनवर्स है तो उसको हमने छोड़ा है. जैसे मेकिंग द क्रॉस, किसका किसका इनवर्स हमने ढूंढ के एक साथ ग्रुपिंग किया है. नाउ कम टू द नेक्स्ट एलिमेंट 3. एंड व्हाट इज द इनवर्स ऑफ 3 modulo 11?
4.
4. Yes, 4. And converse, what is the inverse of 4 modulo 11?
3.
3. That's why I put 3 and 4 side by side because they are inverse to each other and make a group. So एक group ये मिला 2 and 6 का, 2 into 6, another is 3 into 4. And now Come to this element 5. And what is the inverse of 5 modulo 11?
9, sir.
9. Yes, 9. You're good. And reverse also, what is the inverse of 9 modulo 11?
5.
5. So that's why you put 5 and 9 side by side in the next line, this line. And so 5, we have calculated the inverse of 5 and 9 already. Come to the another element 7. What is the inverse of 7 modulo 11?
8.
8. And converse, what is the inverse of 8 modulo 11?
7.
7. So that's why I put 7 and 8 side by side in the next line. You can see that. This one. And you know that inverse of 10 is itself. That's why this element don't make pair of any other element, because this is the element which is inverse of itself. तो इनवर्स एलिमेंट को एक दूसरे का पेयर बनाना, because 1 and 2 it's inverse of itself, that's why they don't make a pair. Now think in modulo 11 system, this product 2 into 7, 6 is nothing but 12, and 12 is modulo 11 system is nothing but 1. That's why in the next line, this product, instead of writing 2 into 6, I write the 1, because in modulo 11 system this element is nothing but 1. Similarly, 3 into 4 is 11, 12, and 12 is in modulo 11 system is equal to 1. That's why I write the 1 here again. Come to the 5 into 9. This element is nothing but 5 into 9, kitna aayega? 45. 45, and in modulo 11 system, 45 is same as 1. That's why I write 1 here. And similarly for 7 into 8. In fact, कोई एलिमेंट और उसका इनवर्स का प्रोडक्ट लोगे तो वो उसका मॉडुलो पी सिस्टम में 1 ही आने वाला है, बिकॉज ए इनवर्स सेटिस्फाइंग द ए इनवर्स इज कांग्रुएंट टू 1 मॉडुलो पी, यू नो दैट, तो हमेशा रिमाइंडर 1 ही आने वाला है. So that's why making the group of those elements which are inverse to each other. So I will do same thing in the your proof part. So see that p minus 1 यहाँ remaining दिख रहा है here. This is in p minus 1 10 in this case. Here p minus 1 is remaining element is there, because this in case of p is equal to 7, this is 6 p minus 1, and in p is equal to 5, then this is a p minus 1 element. So I did same thing in the your proof part. So I consider this product p minus 1 factorial, and this is nothing but this one, and of each term with its inverse modulo p. हर एलिमेंट को उसके इनवर्स के साथ पेयर बनाना है. I did same thing in the 3 examples, and with that, then after making the pair, we just observe that in modulo p system will only get the element p minus 1. So that's why p minus 1 factorial, same thing, we see that p is congruent to p minus 1 modulo p, and p minus 1 in modulo p system is equal to minus 1. That's why p minus 1 factorial is congruent to minus 1 modulo p. That is our proof. The proof is not lengthy. There is only 2 concepts you have to be clear about: how to make the grouping of those elements which are inverse to each other. And another claim is that in p system, if you consider set S which has element 1 to p minus 1, then that set S will have only 2 elements which are inverse to itself, and that element is nothing but 1 and p minus 1. Otherwise, every element is inverse to another element. And based on this proof, something I write here. So what your Wilson theorem say that p always divide this term p minus 1 factorial plus 1. So also I verify this statement of Wilson in these 3 examples. When p is equal to 3, Think about. Then p minus 1 factorial plus 1 is something but 3 minus 1 factorial plus 1 is nothing but 3. And you know that this is divisible by itself 3. That means this example demonstrates your Wilson theorem. And also when p is equal to 5, think about this term p minus 1 factorial plus 1. And if you calculate, this is nothing but factorial 4 plus 1 and factorial 4. What is factorial 4? Anyone? Please reply.
24.
Factorial 4 is 24.
24.
24 and 24 plus 1 is 25. And 20, you know that 25 is always divisible 5. That means when p is equal to 5, the Wilson theorem is also verified. In the next example, I assume that p is equal to 7. In this case, think about this term 7 minus 1 factorial plus 1, and 7 minus 1 factorial means 6 factorial, and 6 factorial is the same as कितना आने वाला 6 factorial
720.
720.
720. 720 plus 1 721, and you can see that 721 is always divided by 7. You can cross verify that 7 divides 721. That means also in this example when p is equal to 7, your Wilson theorem is verified. So Wilson theorem say that when p is a prime number, then p always divides the term p minus 1 factorial plus 1. In congruence term, we can write that p minus 1 factorial is congruent to minus 1 modulo p. And this is a one interesting method to find a remainder when a factorial term is divided by some prime number. तो यहाँ पे जो रिमाइंडर जिसका निकालना है यहाँ फैक्टोरियल टर्म का यदि है तो इंटरेस्टिंग टर्म है तो आप आसानी से निकाल सकते हैं. Some issue, something written somewhere, some comment. I don't know. Sudarshan is saying that you are not audible. Maybe
Yes,
some
sir.
network. Huh?
Now
Now it's
आया sir.
maybe some network issue. I was trying to join by 12 p.m. today, but again there is a network issue, so I got late around 15 minutes because of network issue. Now, come to the some exam. Based on this today discussion, I have write some problem and also solution we're going to discuss. Like see, suppose we have a number n factorial, and I ask that find the remainder when factorial n is divided by 11. Can you manually find the remainder when this factorial n is divided by 11? Please try manually. Otherwise, we have Wilson theorem. What is the remainder when factorial 9 is divided by 11? फैक्टोरियल 9 कितना आने वाला है कोई बताए क्या? कैलकुलेटर को बताओ तो फैक्टोरियल 9 कितना बड़ा नंबर है? Anyone?
सर 3,62,880.
It's a huge big number, very big number. And so can you divide 11? You can find the remainder after dividing 11, please. Because another we have a Wilson theorem. People say why mathematics has so many theorem, proposition, and lemma. Because of this is the issues. We cannot find your answer manually because see there's a big data. 9 factorial is very small. 9 is very small number. Even 9 factorial is very small number. Suppose I give the 25 factorial. So it is very. I think this is a very large number.
One remainder आता है सर.
One remainder. Okay. So one remainder. Now we are going to use the Wilson theorem and quickly find the remainder. I think your answer is correct. So see, what Wilson theorem, see that your P is 11, you choose P is equal to 11. P is equal to 11, this 11, you know that a prime number. I think all of you are agree that 11 is a prime number. Now we are going to use the Wilson theorem. Wilson theorem say that 11 divides 11 minus 1 factorial plus 1. In congruous term, 11 minus 1 factorial is 10 factorial is congruent to minus 1 modu 11. हम कहीं कहीं ये ब्रैकेट यूज करें, कहीं यूज नहीं हो रहा है तो उससे कंफ्यूज ना हो रहा, दोनों सेम है, कहीं हम बाय मिस्टेक हम ब्रैकेट नहीं यूज कर पा रहे हैं, ठीक है। बट जैसे कि थ्योरम के स्टेटमेंट में ब्रैकेट नहीं यूज किया, मैं देख रहा हूं यहाँ पे, तो ब्रैकेट इग्नोर भी कर सकते हो, लिख भी सकते, दोनों सेम। कुछ बुक ब्रैकेट मानता है, कुछ हटा देता है। तो सी देन using Wilson theorem will get the 10 factorial is congruent to modu 1 minus 1 modu 11। इसका मतलब ये है 11 से 10 फैक्टोरियल को डिवाइड करोगे तो रिमाइंडर क्या आने वाला, कोई बताया क्या? When you divide 10 factorial by 11, what is the remainder? Just by looking this statement, can you see? Huh?
10, sir.
Minus 1.
Minus 1.
Minus 1 can not be remainder. You know the remainder is always positive number.
10, sir.
10, yes, thank you. 10 is a remainder because minus 1 is equivalent to 10. Because see that here minus 1 plus minus, you know the remainder cannot be a negative number. So, but minus 1 is equivalent to 10 in modu 11 system. That's why your remainder is 10 when you divide 10 factorial by the number 11. So don't write minus 1 is a remainder. Remainder cannot be a negative number. So see that. Now, but our goal is to find remainder when factorial 9 is divided by 11. So what I did, I decompose 10 factorial and write in this line. 10 factorial can be written as 10 into 9 factorial. I think all of you agree. So you write 10 factorial is 10 into 9 factorial. And then this is congruent to minus 1 modu 11. Same thing. So by using the Wilson theorem, I got 10 factorial congruent to 1 minus 1 modu 11. And then I write 10 factorial in this way. Then 10 factorial can be written as 10 into 9 factorial congruent to minus 1 modu 11. Now, our goal is to find remainder when 9 factorial is divided by 11. So, always you remember your goal. When you are proceeding the solution, you always remember what is your goal. Now, suppose anyhow we remove 10 from this left side of this equation, then what will get here? That will be the remainder. What will you get? The positive number which is less than 11 will be the remainder here. So we try to remove this 10 from the left side. So there is a method. I will try to find inverse of 10 modu 11. Can you tell me the inverse of 10 modu 11? Anyone?
10, sir.
10, sir.
10, sir.
10, good, 10, yes, 10. And 10 is same as minus 1 in modu 11 system.
Yes, sir.
10 minus 1 same is modu 11 system because 10 is, that's why, because we have one module. So that's why 10 is right here. 10 is congruent to minus 1 modu 11 system. Okay, modu 11 में अब कोई modu P system में P minus 1 का inverse खुद होता है, तो यहाँ P is 11, then inverse of 10 is itself 10, but 10 is congruent to minus 1 modu 11. So 10 के जगह पर हमने क्या replace किया? Just you instead of 10 I write the minus 1 because 10 and minus 1 is same number in modu 11 system. तो 10 और -1 सेम नंबर है मॉड्यूलो 11 सिस्टम. जस्ट आई रिप्लेस 10 by -1 in modulo 11 system. So I write -1 instead of 10. So that's why I got this equation. -1 into factorial and 9 already there here, and -1 modulo 11. And both side minus there, so just remove minus. So I got 9 factorial congruent to 1 modulo 11, and finally 9 factorial is congruent to 1 modulo 11. And from here, that means when you divide, because यहाँ पे जो ये है निगेटिव नहीं है, तो कह सकते हो कि ये जो बचा हुआ है रिमाइंडर है. जो निगेटिव होगा फिर दूसरे डायरेक्शन में मूव करना पड़ता है. That means when you divide 9 factorial by 11, we'll get the remainder 1, and that is your answer. I think some of you, I think Sudarshan, have tell the correct answer. Your answer is the 1. Now, another question. You just I give the small number 8 factorial, and I ask that what can be the remainder when 8 factorial is divided by 11. Can you tell me manually, anyone? What is the remainder when 8 factorial is divided by 11? Anyone, please try first manually. तब आपको लगेगा कि इस थ्योरम से भी मैन्युअली दोनों में आंसर सेम आ रहा है. This data is small, that's why I'm asked for the manual calculation. If data is big, I'm not going to ask calculate manually. It is not possible to find a big calculation. You conclude a big calculation.
5, sir.
Yeah.
5.
5.
5, sir.
Correct? 5. Okay. So try. I think your answer is correct, and we'll get same answer to 5 by using Wilson theorem. So because here P is equal to 11, I choose P is equal to 11. So Wilson theorem say that this 11 will divide 11 minus 1 factorial plus 1. In congruent term, we can write that 11 minus 1 factorial means 10 factorial is congruent to mod 11. That means when you divide 10 factorial by 11, we'll get the remainder 10, not minus 1. Because minus 1 is not the remainder, and not the remainder. Remainder is always positive number. Now, because your goal is to find remainder when 8 factorial is divided by 11, so I'll decompose 10 factorial in this way and write 10 factorial in this way. 10 into 9 into 8 factorial. I think all of you are agree. You can write 10 factorial in this way. And then instead of 10 factorial, I replace 10 factorial by this number, 10 into 9 into 8. And this is congruent to minus 1 modulo 11. Now come to next line. Because your goal is to find the remainder when 8 factorial is divided by the number 11. So anyhow, we are going to remove the term 10 and 9 from the left side of this equation. And for that, what I did, I just observed that 10 is congruent to minus 1 modulo 11, and also 9 is congruent to minus 2 modulo 11. Instead of that means in modulo 11 system 10 is same as, you can say that 10 is same as minus 1. दोनों का वैल्यू सेम रहेगा. And in modulo 11 system 9 and minus 2 is same number. So just I replace 10 by minus 1 and 9 by minus 2, and I get this line, this equation, minus 1 into minus 2 into 8 factorial is congruent to minus 1 modulo 11. So after simplification, this is the nothing but minus 1 into minus 2, 2 into 8 factorial is congruent to minus 1 modulo 11. Modulo 11. So I got 2 into 8 factorial is congruent to minus 1 modulo 11. But this is not your goal, because our goal is to find what is the remainder when 8 factorial is divided by 11. So anyhow, we are going to remove this term 2 from the left side. And that's why what I did, I just multiply this equation by the inverse of 2 modulo 11. You know that what is inverse of 2 modulo 11?
6, sir.
6.
6.
Six.
So we multiply by 6 in this equation, then we get, sorry, this is the 6 into 2, c dot is something, that is dot has something typo error, c ऐसे कैसे आ रहा है, something typo error, that is 6 multiply with 2 into 8 factorial. इसको ऐसे रीड को 62 नहीं है, 6 into 2 है, सॉरी ये टाइपो एरर है, कहीं गलत हो गया है टाइप करने में. 6 into 2 into 8 factorial congruent to 6 into minus 1 modulo 11. In modulo 11 system is nothing but 1. That's why 1 into 8, and minus 6 in modulo 11 system is nothing but 5. You see that in left side I got the 8 factorial and right side a 5 modulo 11. That means when you divide 8 factorial by 11, we will get the remainder 5. That means your answer is matched. Manually also you get the remainder 5, and using this method you also get the remainder 5. That means the answer is correct. Now same again, I give a number 7 factorial, and also I will ask for the remainder when this number factorial 7 is divided by 11. Please again you try to find the remainder manually.
Sir, 2.
Sir, 2.
Sir.
2.
2, sir.
I think we will get the 2, because same thing. See, we're going to discuss that. See that, because again you get the, we choose the prime number p equal to 11. Your time is now over, and then use your Wilson theorem. Then in first line you get the 10 factorial is congruent to minus 1 modulo 11. Then I write 10 factorial in this way, because your goal, you have to always write down your goal. You have to find the remainder when 7 factorial divided by 11. So it decompose 10 factorial in this way, and then we replace 10 by minus 1, because 10 is congruent to minus 1 modulo 11. 9 by minus 2, because 9 is congruent to minus 2 modulo 11. 8 by minus 3, because 8 is congruent to minus 3 modulo 11. So after replacing this 10, 9, 8 by minus 1, minus 2, minus 3 replaced respectively, we will get this equation, minus 1 into minus 2 into minus 3 into 7 factorial is congruent to minus 1 modulo 11. And this is nothing but just to multiply, you get the minus 6 congruent to 7 congruent to minus 1 modulo 11. And finally, just you remove the minus 1 both sides, then you get the 6 into 7 factorial congruent to 1 modulo 11. And now we have to remove this 6 from the left side. That's why we just multiply with the inverse of 6 modulo 11. And what is inverse of 6 modulo 11? Anyone? 2. Just multiply by 2 both side, then you get the 2 into 6. Sorry, same mistake here. 2 into 6. It's not 26 into 2 into 6. Both side. So this one 2 into 6 12. 12 is same as 1 in module 11 system. So we get this one. 7 factorial give the remainder 2 when divided by 11. So your answer is correct. That means your manual answer is also match with this answer. That means your answer is correct. Now I change prime p. Instead of p is equal to 11, I take p equal to 17, and he asks same question: what is the remainder when 15 factorial is divided by 17? So I also solve this one. You can please read out solution. Also I ask that what is the remainder when factorial 14 is divided by 17. I solve this question. Please read the solution. And same thing this one. So many questions I try to solve, and also I ask some exercise based on the Wilson theorem. Please go and try. I will send this PDF by today evening because there is some typo error. I have to correct those typo error, and then we'll send this PDF by today evening. Okay. Thank you. Thanks to all of you for today lecture.
Thank you, sir.
Thank you, sir.
Thank you.
सर
Yes,
सर
please, yes.
सर पूछ रहे थे सर, ये टेस्ट कब लीजिएगा सर? एक इतना हो गया।
अभी ये नंबर थ्योरी कोर्स खत्म हो जाने दो, क्योंकि सी दैट ये
यस सर।
इस कोर्स में 4 चैप्टर मिलेगा, 4